Okie dokie. So today we're going to go ahead and talk about how to solve tension equilibrium problems, a classic example in AP Physics. So we know the first thing we always do when we get to a problem in AP Physics involving forces, or any physics course involving forces, is we draw a free body diagram. So we have good old force of gravity acting on this 15 kilogram mass, which is what? 150 newtons. We have tension pulling up. We have this tension pulling down. Just from that little junction point right there, we have tension B, and then this is going to be tension A pulling this way. Cool. And our goal for this problem is to find the tension in rope A and rope B. Cool. So let's go ahead and think about this. So a couple of things. Let me just draw a little angle. So this angle is 50 degrees. So this angle we know is 50 degrees using like alternate interior. Awesome. So now that I look at this, I need to next go ahead and draw my coordinate system. So I know anything in the y direction is, I'm going to say vertical, and anything in the x direction is horizontal. I'll say to the right is positive, and then I'll say upwards is positive. Cool. So now I need to go ahead and look, are there any forces that are not just x or just y, but both directions? So tension looks like that's just the y direction. Tension right here is just the x direction, and tension B is both. So we're going to go ahead and split tension B into our x and y directions. So I'm going to call this TBY, and then I'm going to call this TBX. So now I'm going to go ahead and redraw the free body diagram. So when I redraw it, I'm going to go ahead and just draw it as TBY, TBX, going to draw it as tension pulling down and tension A. So whenever I'm doing my thinking, this is what I'm going to draw for my good old free body diagram. So looking back at this picture, I know nothing is moving. So if nothing is moving, the tension supporting this 15 kilogram object has to be the same as force of gravity. So tension is going to be 150 newtons here. So I'm going to go ahead and label that on my picture. So I know that this tension right here is going to be 150 newtons. Cool. So now let's think about it. What rope supports the 15 kilogram? Well, rope A is just horizontal, so it's going to be some part of rope B that supports this 15 kilogram object. So, okay, let's think about this. If it's not moving at all, I think of like a giant game of tug of war. Tension B in the y direction has to be 150 newtons too. Cool. So I'm going to go ahead and label that on my picture. I know this is 150 newtons. So now let's go ahead and draw the picture. So I know this is 50 degrees. This is 150 newtons. Cool. And now I want you to think about how can you find the tension in rope B, and then how can you find this side too. Go ahead and pause the video, do it yourself, and then check back in. Cool. So I'm going to go ahead and put my Sohcahtoa up. So I know I'm going to have to use trig. If I know an angle and I know like a side, I'm going to have to use good old trig. So let's set it up. First one I know, let's see, it's opposite and hypotenuse. So we can do sine of 50 degrees equals what? Opposite 150 over hypotenuse, which is B. Cool. Go ahead and do some handy dandy trig. And then I get B to be 196 newtons after I solve. And again, make sure your calculator is in degrees and not radians. Cool. So I know B is 196. Okay. Now let's go ahead and just solve for this other side for fun. So, okay, I'm going to go ahead and solve that side. So let's say I'm comparing this side and this side. Well, that looks like to me, that's good old tangent. So tangent of 50 degrees equals opposite 150 over adjacent, which is TBX. I go ahead and plug that into my handy dandy calculator, and I get TBX to be good old 126 newtons. Cool. So let me put that on my picture. So TBX I know is 126 newtons. So if I know TBX is 126 newtons, and this thing is not moving side to side, then tension A has to be the same thing, and that is going to be 126 newtons. So I know that rope A, the tension again is 126 newtons, And for B, the tension is 196 newtons.